let's see what they have given in the question. They have mentioned pole. Pole is how much? 4 pole. Voltage, then they have mentioned that is 220 volt. They have mentioned lap connection means A is equal to P. They have mentioned that this is for DC shunt motor. Okay, has 36 slots and each slot containing 16 conductor. So from here we can calculate the value of Z, that is 36 slots multiplied by 16, right? Then they have given us the current is how much, that is they have mentioned 40 ampere. The field and armature resistance are, field resistance means the shunt resistance means RSH is given, that is 110 ohm. Okay, and armature resistance is denoted by RA. Why they have said field resistance is shunt resistance? Because they are talking about the shunt motor. That's why field resistance is shunt resistance, and armature resistance they have mentioned that is 0.1 ohm only. Now next they have said that how much like motor develops an output power. Power also they have mentioned, but this one is the pole, don't confuse it. And power they have mentioned that is 6 kilowatt, so we need to convert it, that is 6000 watt. Okay, and flux also they have mentioned that is 40 milliweber. 40 milliweber means 40 into 10 raised to power minus 3 weber. Correct? Now, according to the formula, like what they have asked, I'll write down all the formula. They ask you the speed. Speed is denoted by N here. Okay. Next, they have asked you the torque. Torque formula I just told you, that is PZ divided by 2 pi A multiplied by phi into IA. Next, they ask you the shaft torque. Shaft torque is basically the useful torque. Whenever they'll say shaft torque or useful torque, one and the same thing. Okay, don't get confused. So there is a formula for useful torque or shaft torque, that is toe shaft is equal to 2 pi n divided by 60 multiplied by p out. Okay, so you have to remember these formulas in this. Clear? Torque shaft, we are having separate formula, that is 2 pi n divided by 60 p out. Now we have to see, suppose we need to calculate torque. Torque is p we know, correct. Z also we know, correct. 2 pi we know, correct. A also we know, that is p only. Phi we know, correct. Ia also we know. No, we don't know Ia. They have given you the total current. As you can see that it draws a current 40 ampere from the supply. Total current is different and armature current is different. We need to calculate this armature current. Okay. Now see how can we calculate this armature current. First I need to draw the diagram. PZ divided by 2 pi into phi into Ia. All things we know, but we torque shaft formula is 2 pi n divided by 60 multiplied by the output power. P out means P out here is represented by output power. Okay. Tau, yeah, tau A, or we can say tau average, one and the same thing. Okay, torque developed, mainly it is a torque. Now we have to calculate armature current. Okay, how can we calculate armature current? I am drawing the diagram for the DC shunt motor. Shunt means parallel, right? Shunt means parallel. So this is the shunt winding, that is denoted by ISH. In this, armature is going inside, that is denoted by IA. This is for I. I is the total current. So it is for motor, so all the currents are going inside the motor, right? You know the basics now. This is RSH. So according to this, I would be equal to how much? IA plus ISH, correct. But we want which current? Armature current. Armature current is I minus ISH. I current, total current they have mentioned. How much they have mentioned? That is 40 ampere. So I mentioned the total current, that is how much? 40 ampere. ISH we don't know, but you know, like it is plus minus V, right? So if we'll apply the parallel rule, you know, in this shunt winding and this armature winding, these are connected in series or in parallel? Tell me. This is the armature, okay? This is the winding. Now tell me, these are connected in series or in parallel? So in parallel voltage would be same or different? Same. So we can say that here also it is consumed V voltage V, and this shunt winding is also consumed V voltage, right? Because we have given V voltage. This is the basic diagram of the DC shunt motor. This is the basic diagram of the DC shunt motor. So ISH is how much? That is V by RSH according to Ohm's law. I is equal to V by R. 40 they have mentioned. Voltage, let's see. Voltage also they have mentioned that how much voltage they have said. That is 220. Okay, let's see. RSH is mentioned. RSH is also mentioned. That is 110 ohm. So from here we can calculate IA, right? Yes or no? From here we can calculate IA, then we can put the value of IA here, we'll get the value of torque. Okay, now move to torque shaft. We know 2, we know pi, we know n, no, then we need to calculate, we know P out. If we'll get the value of n, then can we get the value of torque shaft also, shaft torque? So now our focus is to calculate n, that is we are having formula E is equal to Pn. Yeah, IA value was this one. Wait, E is equal to, now our focus is to calculate speed, right? For this, P is known, Z is known, phi is known, A is known. So for calculation of N, we should know the value of E also, correct or not? But we are having separate formula for E. E is equal to how much? For motor it is fixed, that is V minus IARA. You can note down this formula. This is the EMF equation for DC motor. Okay, once we'll get to know about the E value, then we'll get to know about the N value, and then we can put it here, right? Then we can put here, N value will get it, and then we'll get the value of torque shaft. So now our focus is to calculate N value. For N value we want E value. V is mentioned how much? 220 volt. IA we calculated above, right? And RA also they have mentioned, that is only 0.1 ohm. So after solving it, we'll get the value of E, then we can put it at here, then we'll get the value of N, then N value we'll get, and then we'll get the value of shaft torque. Okay, for this, now first calculate IA value, then I'll tell you how to put it on in all the equations. Clear?